Okay. Uh, Good afternoon, Mr. Ronald, Mrs. Riana, Mr. Felix, Mr. Rianto, Mrs. Christine, Professor Yun Sanjo, and Mr. Stephen Lin. My name is Jovian Rivaldo. Today, I would like to present my final assessment about implementation of Six Sigma, DMAIC, and the motor spare part industry. Case study, motion technology, electric and machinery, Taiwan. So this is the content of my presentation today. There's introduction, result assumption, method and methods, results, conclusion, and suggestion. Okay, I will first explain about introduction. Each company strives to provide good quality product in order to meet customer satisfaction that can be achieved by good quality management system. The MTM is the company that produces brush and brushless DC motor. Brush and brushless DC motor usually are used in medical appliance, electric wheelchair, electric scooter, elevator, and transmission system. The MTM company still use simple quality management system, such as using PDCA and system tools. They need to improve the quality management system in the company to reduce the number of defects product. The company cannot implement high level of quality management system in a short time. They need to do it step by step. Implementation of Six Sigma can be the first step to implement more advanced quality management system. Okay, this is the research assumption. This research was done at the MTM. The research was done using primary and secondary data. The object of this research only focused on brushless motor products. Okay. Next is material and methods. The Six Sigma method is data-based method used in decision making to improve process, system, or product. There are 5 stages in Six Sigma. The first one is define, and then measure, analyze, improve, and last one is control. This is define stage that useful for identifying customer specification for good quality product. There are 2 tools that are used in this stage. The first one is SIPOC diagram that is used for describing business process flow from ordering material from supplier to delivering products to customer. The second one is critical to quality that is used for determining the standard of good quality products based on customer specification. And next is measure stage that can be used for measuring the current condition quality management system in the company. There are 2 tools that are used in this stage. The first one is this DPMO, or defect per million opportunities, that is used to find out the possibility of producing the defect product in a million production. The second one is control chart that is used to determine whether the production is running well or not. And then the third stage is analyze. Analyze can be used for identifying the causes of production failure that produce defect products. There are 3 tools that are used in this stage. The first one is Pareto diagram that is used to show the number of complaints in diagram form. And the second one is fishbone diagram that is used to describe the roots of the problem based on 4 main factors: machine, man, method, and material. And the last one is FMEA, or failure mode effect analysis, that is used to describe the causes, impacts, and solution for roots of problems. This is the FMEA scoring rubric that is used to obtain the RPN score based on 3 scales. The first one is severity scale, and the occurrence scale, and detection scale. And next one is improve stage that can be used for finding the improvement solution to overcome the top 2 priority problems using 5W plus 1H: what, who, why, when, where, and how. And the last stage is control, that can be used for monitoring the progress of improvement that have been proposed. And now we go into the results. On the define stage, we can see the SIPOC diagram that show us the business process flow from brushless motor production that are starting from ordering each material from supplier that will be used in the production process to produce brushless motor products and then delivering it to customers. And the next one is critical tool quality that show us the standard of high quality brushless motor based on customer specification. There are 5 criteria that should be fulfilled by a brushless motor. Motor can work properly, not appearance defect on the product, normal voltage on the product, brake can work properly, and normal sound motor. And this one measure stage. But before we go to the measure stage and calculate the DPMO value, the data that we use to calculate the DPMO value must be tested first. Data will be tested by normality test. Data can be concluded to be anormally distributed if the p-value is over than 0.05. This is data that we test production brushes 2020 and 2021, and then defective brushes 2020 and 2021. All of the data that are used in DPMO calculation are normally distributed, so we can use the data for calculating the DPMO value. And this is the defect per million opportunities. The average of DPMO in 2020 is 301.24, and in 2021 is 152.65, which is decreased by 49.33%. After that, DPMO value will be converted to sigma level. In 2020, the sigma level is 4.93, and in 2021 it is 5.11. And this is on control chart. You can see so many points that are out of control limit. In 2020, there are 10 points that are out of control limit, and in 2021, there are 7 points that are out of control limit. And we analyze this for Pareto diagram that show us the most number of complaint is bad appearance with 33.3% of the total complaint, and then abnormal sound, abnormal motor, abnormal brake, and abnormal voltage. And this is the fishbone diagram of bad appearance which is analyzed to find the roots of the problems based on 4 factors: man, method, machine, and material. And this is fishbone diagram of abnormal sound, and abnormal motor, abnormal brake, and abnormal voltage. And next one is failure mode effect analysis of bad appearance. The SOD scores are obtained from the FMEA scoring rubric that has been previously displayed. RPN scores are obtained by multiplying the SOD score. This is for abnormal sound, and then abnormal motor, abnormal brake, and abnormal voltage. And this is the recap of the total RPN score for each complaint. The complaint with the highest RPN score means it has the greatest risk. So the complaint must be resolved as soon as possible. The complaint with the highest RPN is abnormal voltage, and the second one is abnormal sound. For abnormal sound problems, 5W plus 1H is used to overcome problems caused by poor material selection, no maintenance schedule and check on the audiometry noise test machine, and audiometry tests that are not carried out in special room. In abnormal voltage problem, 5W plus 1H is used to overcome problem caused by poor material selection, no inspection policies and rules, and small number of inspection to lack of time or end worker. And there are 6 proposals that obtain at the improved stage that to be able to overcome the problem of abnormal voltage and abnormal sound. And the last one is control stage. There are 3 stages that used to monitor the implementation. The first one is weekly audio noise machine check sheet that used to monitor machine checking that is done once a week. The second one is operator training sheet that used to check the workers' absence when they follow the training that is done twice a week for a month. The last one is Sigma level control sheet that used to monitor the changes of Sigma level in every month. And after the implementation of the proposed improvement, it was found that there was a decrease in the PMO in January until May 2022, which is results in there's an increase in the Sigma level, which can be seen in the comparison table. And this is the conclusion of this research. The quality management condition of the MTM company can be shown based on the result of DPMO calculation. The company Sigma level is at 4.93 in 2020 and 5.11 in 2021. FMEA results that there are 2 priority problems that must be resolved by company, which are abnormal electrical voltage and abnormal sound. 5W plus 1H solved to overcome this problem by conducting better material and supplier selection, conducting material inspection every time it enters the company, establishing policies and rules related to inspection, providing training to workers to carry out inspection at the end of the assembly process, increase the number of workers, provide a special room to carry out noise audiometry tests, and make maintenance and checking schedule for noise audiometry test machine. After 5 months, the MTM company implemented the improvement solution from January to May 2022. The data obtained showed a change in the number of defects produced in brushless motor products. Sigma level control sheet show that there is an increase in Sigma level in brushless motor production because the PMO value produced has decreased from 2020 and 2021. The Sigma level from January to May 2022 is 5.44, which has increased from 2020, which is 4.93 and 5.11 in 2021. And this is the suggestion for the company that data related to production data, defective products, and customer complaint should written more specific, complete, and consistent. The inspection or sampling process should be carried out according to a standard, such as using the acceptable quality level or AQL. The company should be more brave to the supplier selection that can be done using the analytical hierarchy process method to whom don't meet the company quality standard. If there is improvements on production of brushless motor with the Sigma method, the company can proceed using the Lean Six Sigma stage. However, if not succeed in decreasing the number of defect product in the production of brushless motor using the Six Sigma method, the company can proceed using Design for Six Sigma. Okay, that's all of my presentation. Thank you.
Thank you, Jovian. For the first opportunity, we would like to invite the one and only Director, CEO